Good morning, all. This is Miss Billerbeck, and today we're going to start section 14.1, which is scale drawings. So we've seen scale drawings a lot. So for instance, if we have the original heart right here, we have a reduced heart and an enlarged heart. So if I were to use math to write a ratio, and this is my original, it would be a 1-to-1 reproduction of the original heart. But this one, when I reproduced the heart, I made it a reduction by 1/4. So it's 1/4 the size of the original heart. But if I wanted a big heart, say I needed to send a really big heart to somebody special, I would enlarge it. So I would make it 3 times or bigger, perhaps, for an example. You can make it 1,000,000 times bigger if you want, depending on who you're sending it to. So this first number here represents the actual drawing. Okay, so this is the actual drawing measure. So that's 1. But this number here is the actual measure in reference to the original. So this is 1/4 of the original. This is the original. So this is actually 1/4. So that's what's telling us that it's a reduction if this is a smaller number. If it's bigger, it means it's 3 times the original. Okay? So this is just the measure of the heart on the paper and that it's 3 times the original. So that's how you would read it. So let's look at some specifics. So a scale of a drawing is a 2-dimensional drawing of an object that is proportional to the object. Okay, so a scale model is a 3-dimensional model that's proportional to the object. So if we were to make a little mini house or mini city, it would represent a very large city, but it would be 3-dimensional. Versus a scale drawing is more like this. This is a scale drawing. Well, if it was more to scale, it would, this would be more exact. But so these are just scale drawings. So it's a 2-dimensional scale drawing. Versus a scale model is if we actually, created a little mock 3D version to show a client, hey, here's your future building or your building site. We want to make this a lot bigger, so it'll fit 1,500 people. So you can't really bring a model that would fit 1,500 people into a conference room to discuss whether they like the plan or not. So we make scale models. And that helps people to actually see and touch and put their mind into, is this really what I want to spend millions and millions of dollars on? So that's the important thing about scale models. Okay, a scale which is what you're learning right now. It gives a ratio of dimensions in the drawing to the dimensions of the object. Okay, so this is the dimensions of the drawing to the dimensions of the actual object. So this is a 1/4 of the actual object versus this is the same as the actual object, and this is 3 times bigger than the actual object. So all dimensions are reduced or enlarged using the same scale. So this was our original scale. So we reduced comparing it to the original, or we enlarged comparing it to the original. Okay? This is where the book is wrong. So please make sure you know. Scales can be used, scales can use the same or different units. Or different units. Okay, so that's really important. Your book is not correct. When I do engineering drawings or drawings for landscape design clients, I use different units. I am using a piece representing a plan, and it's 1 inch is equivalent to 1/8 feet. It's 1 to 1/8 scale. So I'm converting the plans, which are in inches, to an actual plan in a yard. So I'm converting from inches to feet, or you can convert millimeters to actual meters, depending on how big your plan, what big real shape your plan is representing. Okay, so that's really important, that you note that you can use different units, okay? Because sometimes your plans are for a baseball field, say, and you are just putting it on a little 8.5 by 11 sheet of paper. Of course, you're going to be doing very small units, and those small units are going to represent very huge areas and dimensions. So you may have to use different units. So please note that your book is wrong in that regard. Okay, ratios are unitless, but scales are not. Okay, so express each of the following scales in, and I'm putting in unitless form, okay, to be very specific. And so we want it 1 to n, and the meaning at the units are the same. Okay, so this is what your book wants you to practice. Okay, this may just work perfectly with the plan that's being made, but this is what your book wants you to do. So we know that there are 3 feet in 1 yard. Okay, whoops. And then we know that there's 12 inches in 1 foot. So we are going to be multiplying 50. So this gives us 1 inch to 50. And we're going to be multiplying. We notice that yards cancels, feet cancels. So we're going to have 50 times 36 inches. So when we multiply that out, we have 1 inch equals, and 5 times 6 is 30. Carry a 3. 5 times 3 is 15, plus 3 is 18, and then we have an extra 0. So we have 1 to 1,800 inches. Now again, if I was doing a real plan, I probably wouldn't want such a huge number here. Our brains don't like thinking in such huge numbers. We like more tangible numbers like this. Okay, this one's a little easier to convert. So if we have 100 centimeters is equivalent to 1 meter, then we can cancel these meters out. So we have 2 centimeters is the same, and then this 70 times 100 is 7,000 centimeters. Now we don't have a 1 here, which we need. So we're going to divide by 2 on both sides. So the scale for this would be 1 to 3,500 centimeters. Whoops, remember we're using unitless, so we don't want our units in here. Okay, so that's what they wanted. Let's put the 1 right near here. Okay, so this one we want to convert to feet because we have a 1 already here. So we have, for 1 foot, we have 12 inches. So 1, the inches cancel, so we're foot to foot, 1 foot, and then this is 3 over 12 feet. And 3 over 12 reduces, so we have 1, 2, and then we could divide 3 on the top and the bottom is 1, and there's 4 3s and 12. So that would be a conversion of 1 to 1/4. Okay, so this would be a reduction. This would be an enlargement. And this would be an enlargement. So there you have it. All right, let's look at example 2. All right, we have a tennis court that measures 24 by 11 meters. It is represented by a rectangle that's 22 centimeters wide on a plan. Okay, so we need to find, this one is the length and this one is the width. So we're going to compare this to this. So we have 11 meters, and that's going to be the same as 22 centimeters. Oops, I need to do it the other way because we want the drawing first. 22 centimeters, and then we have 11 meters. Okay, so we need to convert this over. So we have 100 centimeters over meters. So we have 22 centimeters to, and that's going to be 1,100. Oops, that's 11,000. 1,100 centimeters. Okay, we don't have a 1 here, so we have to divide by 22. So that gives us 1 and, let's do long division here using the dry erase calculator. So top dog goes in the house, so we have 1,100, and we're dividing by 22. So there are 5 22s and 1 10, so that's 10 and 11. We drop the 0 down, and there's 0 22s in that, so we have 0. So this is 1 to 50. So that would be our scale. All right, so we found A, 1 to 50. Okay, so write that in there. Okay, so B, the length of the rectangle on the plan. Well, okay, let's do this logically. Okay, if this is 11 and that's 22, this is twice as much as that, but it's just this is centimeters and that's meters. So what's twice 24? Okay, that's 48. And then it'd be 48 centimeters. So we're going to put 48 centimeters here, just doing fast math. Okay, so now let's do it their way. All right, so we have 24 meters. And we don't know what that's going to be compared to, but we can do this ratio here, which is 50 to 1. Okay, so then we multiply this, 50 to 1, and we get 5 times 4 is 20, carry a 2, 5 times 10, 2 is 10, so we have 20 and 0. So we have, let's see, what is going on here? 120 meters. So we would want to change that over to centimeters, but when we do that, it's going to be really big. So I've done something wrong. So let's see what I did do wrong. This is why I like fast logical math, because then you know what the answer is, and then when you do your math, you can just check it. Okay, so it's saying that instead of doing it this way, I should have flipped this over. Aha! So I am going to because this is in centimeters, okay? We're doing centimeters here and centimeters here. Okay, so if I'm going to change this up, see, I make these mistakes just so you can learn. Ha. Okay, so 150, and then I have centimeters here. Okay, so I'm going to, but I need to change this to meters. So I'm going to do a conversion of meters. So we have 100 centimeters over a meter. Ah, there we go. Do you see? Do you see now? It's going to work out. Okay, so we have 24, and now the meters canceled, times 100 over 50, but we're in centimeters. What's 100 over 50? That's right, it's 2. So we have 24 times 2 centimeters equals 48 centimeters. Voila, it's what we did with fast math, but this is the math that you use. So you take the number for length, and if we don't know what that is, we use this scale factor here. So we put the drawing over the actual, and then if this is meters and we're doing centimeters, we have to do the conversion right here, and then 24, and then we use 100 over 50 to convert to centimeters, which is 2, and we get 48. Well, there you have it. Hopefully my mistake will benefit you. Okay, so let's move on to the last example. Now, this is something that you might do once in your life, is measure up your bathroom and draw up a plan and say, this is what I want. Can you do it? And here's all the square footage. So we have a bathroom floor plan here, and it scales 1 to 40. So we want to find the actual dimensions in meters. Okay, so our drawing is 1, and the actual is 40 times larger in centimeters. So let's see the scale. So we need to take this, and we have 6 centimeters, and we're going to multiply it by 40 times. Okay, so we're going to take this and multiply it by 40 over 1. So this gives us 240 centimeters, but then we need to convert it to meters. So we have 1 meter over 100 centimeters. So this gives us 2.4 meters. So this is this. So 2.4 meters is this length that converts to 6 centimeters on the paper. So 5 centimeters, and we're converting this to the actual. So that gives us 200 centimeters. We convert meters to centimeters here. And this gives us 2 meters. So this side is 2 meters. So there you go. So converting's not too hard. You just have to keep up with it. All right, so with that, you should be able to do your homework assignment, and I hope this finds you safe and well. Have a wonderful day. Bye.